Example number 5 on implicit differentiation. Determine dy over dx given x squared plus 2x sine 4x equals to 0. So for you to determine dy over dx, they are simply telling you to differentiate everything with respect to x, isn't it? You differentiate everything with respect to, so it means you introduce ddx in all terms, isn't it? You introduce ddx because you want to differentiate with respect to x. Is that okay? So the first term here is x squared. We introduce ddx of x squared plus ddx of 2x sine 4y to be equals to ddx of 0. You've introduced ddx on both sides of the equation, isn't it? Meaning you are differentiating with respect to x. Are we together? Then you start. If you differentiate x squared, you get 2x. Then you ask yourself, I'm differentiating an x variable with respect to x. I remain with the dx over dx, isn't it? Are we together? I get dx over, and you know dx over dx is silent, isn't it? You go on plus. If I differentiate 2x sine 4x, you see this is a product of two functions, isn't it? So you use the product rule. So when you want to use product rules, you go to rough work. So you go rough work, you say 2x sine 4y. So instead of saying this 2 is a constant, you can make that 2 to be part of that polynomial, isn't it? So that you say the whole 2x is the function u. Instead of making it outside the bracket, you come along with a lot of simplification which are not relevant, isn't it? So you let 2x to be u, isn't it? And you let sine 4y to be. And remember, you are differentiating everything with respect to x. So you start. If I differentiate u, remember u is 2x. So if I differentiate u, first of all, u is 2x. If I differentiate 2x, I get 2. Then what are you differentiating? I'm differentiating an x with respect to x, meaning I remain with the dx over dx, isn't it? Which is just 1. So I just remain with 2, isn't it? Are we together? Then you go again. Your v is sine 4. Now, if I differentiate v, if I differentiate sine, I get cos, isn't it? Meaning I get cos 4y. Then I differentiate the inner function 4y, I get 4 senior. Are we together? So product of inner function and outer function gives you the derivative, isn't it? Then at the end, you ask yourself, what variable have you differentiated? Y. Are you seeing that? I've differentiated a y variable with respect to an x variable. So it means I've differentiated a y variable with respect to an x variable. I remain with the dy over dx. Are we together? Are we together? So at the end, you apply the product rule. When you have a product of u and v, what do you get? You get uv. If v is prime here, u is prime the other side, isn't it? Are we together? See, that's the product rule. If you have a product of u and v, if v is prime here, u is not prime. If u is prime there, u is not a problem. You add them, isn't it? So what do you get? You go back to your problem. U v prime. U is 2x. V prime is 4 cos y dy over dx, isn't it? So if you multiply u and v prime this times this, you get 2x times 4, you get 8. 8x cos 4y dy over dx. You are done with this part, isn't it? Then this part, u prime v, isn't it? Are we together? U prime v, u prime is 2 senior. Then v, yeah, so 2 times in 4y you get plus 2 sin 4y to be equals to. So you see what you've done? You've applied the product rule. You've applied the product rule, a product of u and v. And while applying the product rule, you've used the implicit differentiation in that rule, isn't it? Are we together? Then in the end, you know when you differentiate a constant, automatically you get, isn't it? Anytime you differentiate a constant, you get 0. Are we together? Then you now go and you simplify. What does the equation want? The equation want dy over dx, meaning they want you to make dy. Remember, dx over dx is silent, isn't it? Dx over dx is silent. So if they want dy over dx, they are telling you to make dy over dx the subject of the formula transposition, isn't it? Are we together? So any term which does not have dy over dx, you take it on the other side of the equation, isn't it? Are we together? So the term with dy over dx is this middle term, isn't it? Which is plus 8x cos 4y dy over dx. These are the terms without dy over dx, they go on the other side of the equation, isn't it? Meaning this 2x going the other side, it becomes negative 2x, isn't it? You've collected that. This plus 2 sin 4y going the other side, it becomes negative 2 sin 4y. Are we together? What do we want? We want dy over dx, meaning we get rid of this coefficient, isn't it? We divide both sides of the equation by 8 cos 4 by 8x cos 4y, isn't it? So that goes with that. You remain with dy over dx to be. Remember, negative 2 is a common factor. If you factorize this outside, you remain with negative into x plus sin 4y over 4x cos 4y, because 2 will cancel out with 8 to go to 4, isn't it? See, you factorize negative 2, which is a common factor outside. Then it means here will remain positive, because negative into positive will go back to the negative, isn't it? Are we together? Then you have negative 2 here, then 8. So that 2 has cancelled with 8 to, you remain with 4, isn't it? Is that okay? So have you seen you've determined dy over dx using implicit differentiation? So the implicit differentiation, if there's a rule of differentiation in between, you use that rule, isn't it? Accordingly.